This is the first part of my generator build, permanent magnet generator, which will have 8 magnets and 6 coils and will be 3-phase power. This is my other disc I've set in position. I've spaced it out with the magnets and the thickness of the coil, and I've glued the nuts on these retaining bolts into position, as I won't be able to gain access when I fix the magnets to the discs. I've allowed 2mm clearance either side of the coil. Optimally it should be 1mm, but with imperfections I cannot achieve that, so I'm going to compromise with 2mm gap between the coil and the magnets. I found out with the air coils on the big window motor that the gap is not too critical, so we'll see when I get it up and running. A quick spin to see how much wobble we've got. Obviously I haven't supported the end of this shaft yet. My template for fixing the magnets to the disc. This is the board in which I'm going to set my coils. I've already marked out where the coils are going. I'm going to cut these out and leave some timber left in. When the coils are placed in, they'll be filled with resin, and I'll probably face both sides with thin formica. This is my jig for winding the coils. It's going to be wound with 1.6mm wire, 100 turns. Okay, this is the board now with the cutouts for where the coils are going. Centre ring. I face this MDF board with 4mm plywood, so when I've got the coils in, I just cut some slots and just chisel out the plywood, makes it easier. So I'll thread the wires through to the outside. Okay, the rotor construction now finished. I've fixed wedges of wood in between the magnets. They're epoxied to the magnets and to the plate, and also fixed with a brass screw. These should keep the magnets in place. They'll be okay for low speed running, but if I intended to take it to a faster speed, then I would fix some non-magnetic material, perhaps brass strip, around the circumference of the rotor, and I can screw it into the wooden pieces there to make it secure, and that would be another asset to stop magnets from potentially flying off at high speed. This is my winding jig complete. I had a couple of bearings spare, so I put them on the 13mm shaft. My coils ready for winding. The coils tied with tie wraps before I take it off the jig. The coils set out in the board, waiting to be wired and fixed in permanently. This is a generator running at 330 revs, just using half of the magnet rotors at the moment. And that's the voltage output. Just hand spun the rotor. That's the voltage with the second rotor fitted. It's quite an effort to fit the second rotor because you have to keep taking it off, putting it on till you get the distance okay. This is a generator running at 155 revs a minute. It's charging a 7 amp hour 12 volt battery. That's the charge going into the battery at the moment. The motor driving the generator at the start was 335 revs, but as soon as I switched the charger on, it dropped down to 156 revs. This is a generator running in the delta formation. I've changed from star to delta as there is less resistance in delta. The motor has increased 100 revolutions a minute to 270 revolutions a minute, and I'm charging a 12 volt battery, 7 amp hour. $13.58 at the moment is the charge. The delta gives a lower voltage, which is about 17.5 volts unloaded, but it gives more amps. Like I say, less resistance. The motor's being driven by another battery, which was 13.30 unloaded. Loaded it was 12.68. Half an hour into this test run, got 13.64.65. As a matter of interest, 13.58 is coming out of the back EMF of the motor. The drive battery now is at 12.59 and the revolutions were at 275 per minute. One thing about the Bedini running the generator is I can get power out the back end and power out the front end, so two sources of power.